My name is Lars, and I'm going to talk to you today about how we at Norkart at my team, have tackled property data with readable code. Just quickly about me, I finished my master's in geoinformatics in Trondheim a few years ago, where I got to mix together geospatial information and informatics. I've been a professional dev for a little bit over 4 years now, all of it in functional programming in F#, just a little bit of C# on the side. I have an extra appreciation for event sourcing and domain-driven design, and in my free time I enjoy throwing frisbees and playing frisbee golf and board games. Just a little bit about my company, Norkart. We're a little bit over 200 employees, and we are doing a lot of work in the geospatial and property domain. As you might have seen earlier today from my colleagues, we do work with zoning plans, mapping systems for municipalities, geospatial infrastructure, and stuff like that. We also do a lot of work on the fees in Norwegian municipalities with water and sewage, renovation, and stuff like that. Also property taxes, which I will talk a little bit more about later. And also 3D models, and other things that are needed when you work with properties and geospatial data. So the common thing here is that we are really good at geospatial data and property data. Just a short outline of what we are going to do here today. I'm going to give you a little bit of a background and introduction, mainly to property taxes, which is our domain that we are focused on, and let's talk a little bit about what is actually readability. Then we'll go into a few things that we have tried to do to increase the readability, isolating the domain, bilingual code, writing code in multiple languages, and a little bit of event sourcing, and then finish up with some testing, hopefully. So, property taxes. Norwegian municipalities, they have the option to collect property taxes from their inhabitants and from businesses that are located in their area. And for most of them, that means if they want to collect this, they need a computer system to handle the data, the workflows, and the communication with the inhabitants. So this is what we at Norkart have made and are continuing to make. For a property, we need to find the value of the whole property. That is what is the basis of the taxes. So let's start with a small example where we follow one single building in one single property. We start with the Norwegian cadastre, which is the national data set for property information. Who owns what is the size of the property, what buildings are there, information about those buildings, and so on. They are maintained by and owned by the individual municipality, but it's a national data set that is maintained and organized. Since every municipality manages their own data, it is they have some certain freedoms in how they are registering their data, how they are using this data. So we need a configuration to make sure that everything maps up nicely. Also, properties are very different here in Oslo or in other big cities, and if you go to a smaller municipality in the rural areas, the prices are different, the types of buildings are different. There's a lot of field work involved. Every 10 years, the municipality sends out a lot of people into the field to take pictures and register what the property is, how it looks like, what is, and makes adjustments if they find anything wrong with the data sets. And then there's a lot of casework at the office. Review of the data, checking if everything is correct, doing the approval process with the politicians to verify that the valuations are correct, and so on. So for our specific little building over here, we can see that this is a single residence, single home residence. It has 100 square meters of ground floor with the residence areas and 25 square meters of what is called alternative area 1. One of 4 fields that they are able to punch in data. And as you can see, this one is open for use. In our configuration for this kind of building, the municipality has said that the residence area, that's living quarters. And that alternative area 1, that's a garage. But when the field worker shows up at the property, they might see that it has a nice view or it's close to a congested highway, so they adjust the value up and down. But they also find that 20 square meters is actually a storage unit and not living quarters. So they detail the data further. Then, back at the office, the caseworker reviews the property. The valuation is confirmed by committee, and a tax bill is sent to the owner, together with all the other information about this property. So the end result for our building might look something like this. Don't worry too much about the Norwegian words, it's just what I've said so far. It is some square footage that is residence, some storage units, and some garage. And they have different sizes, different prices. And this ends up as your tax bill, perhaps. So, is this complicated? Well, it's not exactly rocket science. But there is a lot of things to think about. It is heavily regulated. These are official taxes that are collected out in the open, so we rely heavily on Norwegian law. As I said, every municipality have the responsibility for their own data, which leads to some challenges with perfect and imperfect data, so we need to account for that. It is also a lot of old data, which might not be as complete as the newer data. The example I went through earlier was quite simple. We had a storage unit, we had some residence areas, a garage perhaps. But imagine if you are talking about the apartment block with many hundreds of apartments. There might be a garage in the basement, which some but not all of the apartments own. And there might also be a shop on the ground floor, which may or may not be part of this garage ownership. So we need to handle a lot of weird edge cases all around Norway. There's also a lot of variations in workflow. A small municipality with one part-time worker that is not working on property taxes all year even have different needs than a large municipality with hundreds of thousands of properties, which has much more need for filtering, finding discrepancies, reporting, and working with batches. So we need to make a system that is simple enough for the small ones and advanced enough for the large. Finally, we have the rule of equal and fair treatment. It is very important that we calculate correctly and consistently, because similar properties should have the same value. If different people have to pay different taxes for a similar property, that might undermine the whole system. So, readable code for this. Why is that such an important thing? Well, we spend more time reading code than writing code. or at least I do. So it makes sense to optimize for that part of the coding experience. Also, if we actually manage to write this readable code, it can act as a source of truth for how the system works. Well, it is the source of truth for how the system works, but we can actually check it up if it's readable. If you understand the code, you can explain it to others. You can fix it if something is broke, and you can also extend it and do more with it. But what is readable code? Any suggestions from the audience? Code that is easy to reason about. Very good point. Any others? Good variable names. Excellent. So there's a lot to readable code, but I've put in a few of them. The most important thing about code is that the intention of the code is clear. I would almost say that code where the intention is clear, where you know what this code is supposed to do, is easier to fix than code which does the right thing, but the intention is unclear, because that is harder to maintain and change later. It is also important that there are no surprising behavior here. The code does what, like a little bit like intention. There is no surprising side effects, mutations, writing to a database where you don't expect it. And readable code is also simple code. It is very easy to write complicated code, I find, but it is much harder to write code that is simple and that is stripped down, no funny business. So that's a suggestion for all of you to, if you find yourself wanting to write this really clever piece of code, I've done it many times, don't. So one of the ways we want to achieve readable code is by isolating our domain. As I touched upon earlier, our domain is complex enough on its own. We really don't want to also have to worry about other things like reading and writing, input-output, asynchronicity, error handling. Ideally, we would like to just leave all that at the doorstep and walk into a domain where we can really focus on property taxes. If we can do this, we can also have a common language, hopefully, in this model where we can use the same words as the domain expert and write the code using that. And like, just make this nice island inside our code. It might look like something like this, and there are many names for this kind of pattern, but this is just a walkthrough of it. So we have a request that comes into our API, and yeah, same procedure as always. We do some input I/O. If we need to read something from our database, we do it here, so that we don't have to worry about that later. Then we have a step where we can sanitize and transform our data, just making sure that these DTOs, JSON-friendly types, is more prepared for our domain. We check that it is valid, check for invariance, stuff like that. And then we go into what is hopefully the main part of our system, our domain logic. So here we have pure functions that just takes an input and return an output. They might be large, they might be composed of many different calculations, a lot of things happening, but at the end of the day, they are pure, so they are just calculations. Yeah. This should hopefully make them easier to reason about and make them more readable. And then at the end, we do some outgoing I/O, the O if you want, where we write back to database if we want to do that, return to the caller, that kind of stuff. So, I talked about readable code. I write in my code in F#. I'm not sure everyone here does that. So, who here has done some coding in F#? Around half, I suppose. So, for the rest of the talk, when I do some code samples, not so readable perhaps, but we'll see. Next question, why F#? I will try to answer that one. Well, first of all, at my company, we are mainly doing our new programming in .NET, and I would say there are many functional programming languages other that have some of the same features that I'm going to talk about, but F# lives on the .NET platform, which means that we can write our controllers in C# like we've done before. We can integrate middleware and libraries written by other teams in our company without them having to make some special adjustments for us. So we have the first example of a bilingual or polyglot code base here, where we are writing code both in C# and F#, but we use F# for the core domain. Why? Well, as I'll show you a little bit, we have a lightweight syntax in F#. There's very little clutter in the codes. There is, for better or for worse, it's very straight and to the point. So the little noise that we have gives us more room for expressive logic. We can use good variable names with this extra space. We can make sure that we are putting in that extra little bit of effort for readability. It is also a language where we don't have to worry as much about error handling and nulls everywhere. So this is another thing that we don't have to worry about as much when we code. There's little need for defensive programming that clutters up our logic. And we have expressive types. We can combine different structures to represent almost anything, both by having types that are this thing and this thing, or types that is this thing or this thing. Small code example, and yeah, I'm trying to use a dark font even in my slides. We'll see how this works. Here we just have two types. It is a range of that has a start and an end, from and until, and this start might be a specific time, or it might be an open-ended time. We use this to represent our durations in our code. So here you can see that we have very short syntax. Makes it very easy to do this. You can model everything up with objects or types or records or whatever in many languages, but the ease of use makes it so that this is a pretty standard way of rather create one more of this than skipping it and have one for your specific use case. So here we can also use, this is not too connected to our domain, but it is, here you can use the same words that we use in our day-to-day life, making sure that we are talking about the same things. Just a small example of interoperability with the .NET ecosystem. This local data is actually from a fairly popular library called NoDatime. So here we can use that straight into our F# code base without any extra ceremony. A little bit more of F# code. Here we can see the creation of such a function. Here we have a lot of extra space, as you can see. this might not be the best of examples, but it's fairly clear that if you're used to syntax at least, that this is a create function with a from and until argument. And here as you can see, you have so much space that you can feel to be like, maybe this is a from local date until local date, or whatever you want, being more expressive with your logic. Then you have the pattern matching. Most of our program flow is structured like this. This is similar to a switch statement in C#, where we just switch on the tuple. And here rather than nesting different kinds of if, then, else, it is just a pattern match on the different kinds of types we have. Where we have one way to handle the first instance, and the rest of them falls down to the OK case. I would encourage you to use this kind of structures in your code, where you can be more explicit about what you're trying to achieve. So these are higher abstractions than if you do the if-then kind of stuff, but you are much closer to your domain language here. Given that you have a specific date and a specific date, and then the until date is before the from date, well, then you have an error. The to date must be greater than the from date. And this is how we handle errors in our code. So it's fairly easy to work around, and when you call this function, you actually have to handle this. So you are sure that you are handling your cases, but you don't have to worry about it everywhere else. You just have to worry about it where you actually can see it in your types. Another question about readability. Who here understands Norwegian? Yeah, not everyone. So this is the second step of how readable is our code really, because it is in F#, and a lot of it is also in Norwegian. So for our case, we work a lot with Norwegian-specific laws, and we work with a lot of Norwegian-specific data. We are also a company that has Norwegian as our work language. And if we were to translate all our terminology within property taxes to English, a little bit like I do in this talk, you might create some confusion, some distance. It is not a common language anymore. You don't use the same words as your domain expert or as your user. For our case, it makes a lot of sense to just use the Norwegian words instead. This also goes hand in hand with the isolation of the domain right. We can be very explicit about when we talk about the domain and when we talk about the coding structures. There are a lot of, also a nice bonus of using two languages is the overlapping terms or the overloaded terms. There was even one in the title of this talk, working with property data. You might not have realized that that was real estate properties, but properties in code. Some other examples. The part with the residence areas and the storage units and stuff like that is actually called building functions, which might confuse someone if they encounter that in their code. Same with properties, as I said. Values and tax objects. Which one are we talking about here? Well, if we use Norwegian for our domain-specific words and English for our coding flow, that's another part of our bilingual code base. We use two languages. So it might look something like this. We have an event is an established word, so we just use that in English, but our different kinds of events, they're named in Norwegian. You might also, if you've been to some other talks, either here or sometime else, you might see that these are events, and we do something called event sourcing, in our system. I won't go too much into detail about what event sourcing is, but basically we try to break down our code into smaller steps here as well. If you have an old state and just add an event that happens, you have a new state. Simple enough. Well, then if you have an initial state and then take a lot of events, you also have a new state. So you can store the events instead of your state. And just calculate the state when you need it. So this might be like one of the things that we do in our inbound operations, that we read out all our events and feed that into our domain. This is, for us at least, great for the oversight. We work, as I said, in a regulated area where it's important that there is no monkey business going on with the taxes. So we can see every step of the way what has happened. This case worker did this system did this field worker registered this other thing. So we make sure that it is traceable what has happened. It is also very nice for us when debugging. There's this case in production where something is going wrong. Well, we can see that these 6 events happened in this particular order. So we just have to reproduce that. That we can do in a test. I'll get back to that later. It also breaks up this logic into smaller pieces, right? Because we can follow along on the story of the system. So there was the property was created in the system. Okay, that seems simple enough. This building was changed. Simple enough. These functions were changed. Simple enough. So a little bit about signal to noise. We talked a little bit about using F# for reducing the amount of other stuff we have to worry about. And the same goes when with the rest of the code. Another example here. Here I have translated some Norwegian code into English, and I immediately failed because I used the reserved function keyword. So don't do that. Just imagine that it is a Norwegian word instead, or that we actually said a building function and not just function. It takes one of these events, and in this case, we are supposed to zero out the value of this particular function. It is it should not be counted towards the taxes, and it is fine. You take in a function, you change some variables, you assign some variables to what they were before. But this part here is a bit, I wouldn't say a big problem in this case, but if this was a record with 15 fields, it would be a problem. You just assign the value to what it is, and it is not the purpose of the code. So you get a bit of a messier overview here. Instead, you can use, and this exists in different versions in different languages, but you can use the syntax where you take the function and you just change what you're supposed to change. You remove the noise of what is not the intention of this code piece. The intention here comes across much cleaner. And we also remove a risk that we accidentally set the value to something else that we shouldn't do, mixed up to fields or whatever. Lastly, a little bit of F# snacks. This part here at the end, it is. I don't think I have to explain what it is for you to have some sort of inclination of what this part of the code means. But we can tag our values with what kind of units of measure they are. So the value per square meter, that's Norwegian crowns per square meter. You don't accidentally send in the building ID here, or the total value for that matter. So this is just, it also reads a lot like how you would talk about it. So it's expressive code with clear intent. The next step is managing the complexity of an application as it grows. I'm going to try to challenge you once more. Are there any of you that have felt when you work with a code base over time that it's harder and harder to add new features and reason about your code? It becomes less manageable? Easy question. Just checking if someone has fallen asleep in this evening talk. Well, for us, the most important part has been to split up our domain into separate, smaller chunks. It is a good starting point to isolate the domain, removing all that other noise. But property taxes as a whole is still quite complex, still a lot of things to think about. So you want to ideally not have to worry about all of it all of the time. These smaller chunks will be easier to understand. So as an example of things I haven't talked about yet, but it wasn't relevant for our code sample or the flow earlier, is we have exemptions. Some parts of the municipality are properties that are not supposed to get taxed, like the roads, for example, or a building owned by the government or the municipality themselves. The city hall doesn't need to pay taxes. We have the properties themselves. They don't, for the most part, have to worry about one another. It is a single property at a time, which is also a boundary that you can ignore everything else for a little while. And we also have these valuation decisions that spin out of property and also of the exemptions. You have decided what the value is. Now that is a separate thing. It evolves on its own after that. But you also have these parts of the code which is not part of our core domain, but crops up anyways. We talked a little bit about time periods here earlier. And what we found out was that some parts of our system, as it lives on for longer, these durations started to show up. Well, the first year we had this system, there was no need for duration. Everything was like, this is how it is. But over time, the municipality buys the property or sells the property, or so the exemption has an end date suddenly, or a start date. And the valuation decisions, a guy builds a garage, and suddenly the valuation has changed, so we need a new decision, another duration. And the same with the published taxes, and so on and so on. So being able to do something like this, where all the complexities of these time periods, these durations, are separated out of the core domain, just in a small library on the side, has helped us tremendously to reason about and work with these durations, because it is difficult to think about them at the same time as everything else. Here we can have clear abstractions about what does it mean to be within a period, or fully overlap, partially overlap. And then we can use this as a library into our domain. But we don't have to write this code over and over again and spread it all across the code base. I am pretty sure that we are not doing this enough. So, another check if someone is asleep. With readable code, we don't need tests, right? Well, wrong. Starting a little bit about testing F# code, we are able to worry less about things that the compiler tests for us with nulls and unhandled cases. So we can focus more on testing our core domain rules and how we want the system to function. Starting with the straightforward unit tests. It is important that we check that our code is doing what it is intended to do. Not just at the moment, but also in the future. Especially if you are doing refactoring for readability, then it's very nice to have the tests that make sure that you don't break anything. I talked a little bit about isolating our domain and making sure that that is at the core and don't have to worry about anything else. And that is nice for readability, but it is even nicer for testing, we've found, because the code doesn't have to worry about anything else either. We find ourselves with little need for mocking dependencies and stuff like that, because you just send in some data and you get a response, and then you can just check if that response is what it is supposed to be. We can also do some testing with event sourcing, combining these things, because a lot of the time we have these user cases or stories or something where we have given a certain workflow we want the system to behave in a certain kind of way, and arranging that in the start of the tests would be nice if that was readable as well, right? So by doing this, given a state and then add an event and then add an event, we are able to write tests that also read a lot like when we talk with other people around us. And this is also a very nice way to recreate bugs if we find them. Another good thing about using this kind of system where we just take in an initial state and apply the events to them is that this state can actually change quite a lot without us having to change up brittle tests. We have a testing suite that can transform with the code much more easily than if we wrote this large object that was in a specific kind of way. Another part that might get messy is if you, in some parts of your system, you have large structures that you need to test. Like it could be a JSON that you are returning to your front end, or it might be a document that you upload to a document database, or generating a PDF or whatever. And testing the contents of such a structure can be quite messy. Either you just have to assert parts of this structure, or you have to do a lot of work to check the whole thing. So then, how do you test them? We stumbled upon a gem called Verify that makes this a lot easier for us. I won't go too much into snapshot testing and that part, but it is a way for us to have more precision in and less noise in our code. So we can initialize a state. We can apply these events to it, do some calculations, and just serialize it to a file. The first time this fails, and you accept that this is the new normal, and after that, this code just checks, has it changed at all? And alerts you if you have changed anything. So we can make sure that this large complex system behaves according to plan also on the edges of the system, not just inside the unit tests in the middle, but the whole system works as intended. So a little bit of a summary and our learnings so far. thinking in this kind of way has helped us build an extendable system. It is no longer so that our domain logic is our main bottleneck for developing new features and new advanced logic. We can handle putting in more rules just fine. That is pretty straightforward, but it's at least in the parts where we've made the code as readable as we want it. That's still a work in progress, but it is now much more of a discussion. Can we explain this to our end user? Can we define these rules so that there is no unsurprising behavior, that it is understandable also from the outside, because on the inside we feel like we have a decent amount of control at least. While diving into coding property taxes is still not easy, we do feel like we have brought down the learning curve if we were to onboard new people into this code base. While there are some parts that are really not readable now, but the parts that we have achieved this kind of thinking about has helped the ease of understanding and delegating the work and the understanding to more than just a few people. So hopefully we can go further along on that journey moving ahead. I would also say it's more pleasant to work with. It is nothing that is more frustrating to staring at the screen, trying to understand what some code does, but not understanding it. If the code is more understandable, it is also more pleasant to work with. Some learnings we've done is that for a short while it was mostly me that worked on parts of this code base, while now we are multiple people, and it is much easier to write readable code when you are cooperating with someone. If you have someone that can actually give you feedback on what is readable code rather than taking a guess basically, or what makes sense for you. So it is a team effort to write readable code. As I touched upon, these subdomains and divisions are really important because these smaller blocks are easier to understand, and I do feel like we can achieve more readable code going ahead by working more on this, separating out logic so you don't have to worry about the whole all of the time. And the testability part, I've been very pleasantly surprised about how much easier this becomes when you write these pure functions, and also event sourcing, but mainly the pure functions, because a lot of the things that I hear other people worry about in their everyday life when testing is less of a concern actually, which is a nice feeling. I do have some suggestions for further reading if you want to learn from the experts and not this random dude standing in front of you. 3 books, Domain Modeling Made Functional by Scott Larson, Grokking Simplicity by Eric Normand, and Code That Fits in Your Head by Mark Seaman. All of these books I would highly recommend, and they also are written with code examples in different languages. There's one F#, one C#, and one JavaScript book here. So something for everyone, hopefully. Last slide, I promise. For us, readable code is maintainable code. And readable code is also extendable code. It is more easy to add new features, change data flows, make these kinds of adjustments. We work with external dependencies that might change at any moment. We are in the works now with integrating a new data source from the Norwegian tax authorities. Maybe in some years these valuations will be created by AI, but we do feel like we have a system that is ready for these kinds of changes. it also makes complex work easier. So, but of course it is complex and it is difficult to write readable code. So there's no free lunch here. I would also say that using the native domain language, in our case Norwegian, can make sense. Of course, it's not for everyone. If you have a lot of things that are not Norwegian by nature, or you're an international company, or something like that, it might not make sense. But do consider it. I hope you're taking with you home from this talk a few ideas or things to think about and try out for yourself. And that's it. And I do think we have the time for some questions if there is, well, anyone. No? Well, that's it.